I mentioned earlier one of the properties of mass is that bodies with greater mass are accelerated less by the same force. We're going to use a force as provided by a tape measure. There's a spring inside a tape measure, and we will use that as a force to act on an empty bag of water, a full bag of water, and then we have a surprise guest that will try to accelerate as well. And Koichi now will release the spring on the tape measure. Let's see what happens to an empty bag of water. It accelerates very quickly. So we see that a body with a very low mass accelerates very rapidly. Let's do the same thing now with a full bag of water. We'll stretch the tape measure out to 1 meter.
Okay, ready?
We're out of the field of view. Just bring it around here. And now, okay, now we're in field of view. And now we're ready to test the mass. So a full drink bag accelerates, but at a lower rate than an empty bag. Let's try one more object, a little bit heavier, a lot heavier than a drink bag of water. I'm going to ask Koichi to see if I can accelerate. So I will be on one end of the tape measure, and we'll see if the spring will accelerate me. So I'm holding on to the end of the tape measure. I'm going to lift my feet up off the floor. I'm now free floating inside the Japanese lab. And very slowly, the tape measure spring is pulling me towards Koichi. Much, much slower than the drink bag.
All right.
But even large masses can be accelerated. So the principle there we wanted to show is that bodies with greater mass are accelerated less by the same force being the spring in the tape measure.